Hello everyone, this is Ehsan. In this video we are going to talk about the C++ standard string class. We have a general idea, I hope, about strings, which are basically a model for a sequence of characters. So since in C++ strings are implemented using a class, that means whatever operation that we do on the string will be done using not functions but methods. Remember, methods are usually associated with a class. So the first thing that we need to know, how are we going to include the C string class? It's a little tricky, so let's bear with me. So what you do is you include string, and then what you do is you have to say using namespace std. Well, you can actually skip this part, but however then the implementation or the code becomes a little tricky. You have to always make sure that you write something special like std always. So just to avoid all those, let's just use this and we'll be fine. So always remember to use include string and using namespace. So let's keep them separated here. Okay, so let us create a string. String is a data type, so we write string, the name of the string. Let's say we call the variable name s, and in the variable name we say s is equal to hello world, which basically means so you have to put it with the double quotation sign, which means a string. So it always has to make a string, you always have to use double quotation, whereas a single quotation means a character. So be careful with this. Now if we print this, we can directly go and do this, print s, meaning console out s end line, and if we run this code, it will say, let's wait, hello world. However, in case we don't initialize the string to anything, in usual Java it will, or sorry, in usual C or in Java it will be some garbage value you always have to initialize. However, let's see what happens if we do it in C++. You see, it's basically an empty string. What I mean is, so in C++, since strings are implemented using a class, it has a default constructor, and whenever you create a string s, it is by default, if you don't pass in a parameter or any value, in that case it is by default an empty string. Since strings are implemented using a class, we'll look into some of the basic methods that we can use on a string, or basic messages that we can pass to the string class to get information about the object, string object. So one of the basic methods is length. So what you can do is here you can say string is equal to hello, and you can say pass the length as message to the string object s, and it will return an integer or a size_t data type, which returns an integer value, unsigned integer value. And if we run this, it's supposed to return us 5. Let's run this, Control R, and let's see how it goes. So it returns 5. So we know that there are 5 characters in this string. Now imagine that we want to actually modify the string and change it from lowercase to uppercase. For that, what we can do, we can use a for loop, and we go int I is equal to 0, and then we do int less than, we go till the end, and then what we can do is we do ++, and we just say at index position I, change that position so to upper to s, and I pass the value I, and after that if I return C out less than, and we print s, let's see what happens. So let's run this, Control R, and it says toUpper was not declared in scope. Well, it was intentional mistake. The reason is you have to be very careful how you use this. So you have to use it like this. It's everything everything not capitalized. So let's run this now. So now it changes the lowercase hello to an uppercase hello. In case if there was already an uppercase, for example, H was already uppercase, it will not change that part and it will change the rest. Let's run this. So it's the same result. So basically what happens, we have to be a little careful here, because here this operator here it gives us access to the individual characters at position 0, which is H position. So position 0 is H, position 1 is E, then L, and then O, or position or index, however you call it. And so this operator gives us access to individual characters of the string and not the string. It just gives us access to the individual characters. Remember that string is a list of characters or chars or an array of chars, and that operator that we use to access those individual chars is by using this and placing an index number or a position value inside, which is usually an integer. There is no point giving a float inside. Unlike Java or unlike Java, strings are mutable, meaning that you can actually change the value of a character at a certain index position within a string object, and you can update that location instantaneously, meaning you can do character read and also write the character in the place. In Java, usually you cannot do it. So let's look at this. Imagine that we want to change this position of the string object, so index 0 position of the string object, from capital letter to small h manually. What we can do is we can say string position number 0 is basically a character which is h, so we overwrite this location with h. In Java you could not do it in Java you could not do it. So now if we print s, let's see what happens. It changes to hello. It's no longer capital. And if you look carefully, h is a character, so we are using single quotation. Whereas for a string object, to define a string object, we use double quotation. So now let's have a look into string classes assignment operation. So what I mean is that I assign the value hello to the string object s. Let's assign a new string and give it a name like, I don't know, t, and we call it s. What happens is basically you copy information about s object, so the string object s, and completely create a new string t, which is basically a copy of the s. So if we return this, both of them will be showing hello, which is intuitive. Let's see. And yes, however, what happens if we change one of them? Say for instance, what we do is we basically change s position number 0 to be small h, and if we run this, our hypothesis is t will still be the capital hello, whereas s will be changed to h. Let's run this. So you see that string hello was initially capital hello with h capital, and we changed it to s, index position h to small h, and when we print it, this changes, s changes to hello, all small letters, whereas the t remains the same. So although you're making copy, it's not that if you change something with S, T changes as well. It's not like that. They are completely separated. So the last two things that we want to show is compare. So if we want to compare two strings, say for example T is, I don't know, Balo. In that case, we know that these are two different strings. One holds hello in there, and the other string object T holds Balo. So if we want to test whether these two string objects are the same, what we could just do is this: S double equal to hello, cout same, else we could say cout not same. And let's run this, and since they're different, we assume that it will be printing not same. Control R. I made a small mistake somewhere, so most probably the mistake was, let's fix this. The mistake was basically here. So if we run this, what happens is it says not same, because certainly they're not the same, but you can just test using this equal to sign or equal to, and check if they're same or not same using this or this. We could also get a string from the user, so let's get a line from the user, and let's say we save that line as a string, user input, and since we are using get line, we have to use the SymPio Stanford library, SymPio, so we include SymPio, and if you run this, let's see, and we want to test this thing with the user input, so let's run Control R, and I made a mistake here, string, let's run it again, and let's say, so we want to test S and user input, so let's say we write hello, and it says it's the same. So we can also get data from the user by so we can also get string from the console using get capital L, and for that we have to include sympio.h. And the last thing that I wanted to quickly show was, imagine we want to concatenate strings. So here it's hello, then Balo, and then we get some line. Imagine we want to print hello, Balo, and something that we get from the user. What we could just do is we say S plus T plus user input. So here the plus is overloaded. What it will do, we'll just see here. Sometimes running the code is better than really explaining the thing, because then the thing you see and it's intuitive. Let's run this. It's asking the user for an input. I say wow, and let's give enter, and it says hello, Balo, and wow. So it's basically adding the string at the end. It's like adding at the end. So that's what you called append operation or concatenation of two or multiple strings. So we use this plus operator. We could also use the usual other things, like what we could say, like this. We could say T, update T like this with one space, and then so it's a space as a string, and so we update T, so we add at the end a space, and then we get the user input, and we do all the concatenation, multiple concatenation, and let's run it. Control R, and let's say wow again, So you see the space is given over here. Nice. So that's it for the basics of string, and we'll see something later about string again.